So in class, we did a review. On this video, I'm not doing a review. If you want the review of what we did yesterday, go watch yesterday's video. Yes, sir. You'll see all the things that I said were going to be on the quiz, I guess. So just make sure that you go and know those. Look, I'll do it real quick. It'll be the quickest review you've ever seen. Bam. So all four of these terms will be on the quiz, and I said this on yesterday's video. So know what motion is, know what interacting objects is, know what force is, push, pull, right? Know Newton's law of action and reaction. For every action force, there's an equal and opposite reaction force. And then also know this, boom, bam, all these units right here. So know these units right here, okay? That Newton's is for force, grams is the mass of object, meters is for distance, and liter is for volume and liquid. Okay, cool. Hey, we've done all that in 1 minute. So, okay, that's the quickest review that you'll get from me. Now, on to these things, okay? So on to this. And again, if you want a detailed review, go watch yesterday's video. You can get a detailed review right there, okay? So the key to success is about focus. Focus on the goals, not the obstacles. How are you going to get there? Look for solutions, okay? Cool. There is a social night, so make sure that if that's something that you want to be into, make sure that's the stuff for the social night. We'll talk about that later in class. All right, cool. So let's move along to this thing right here, okay? So interactivity number 7, go ahead and do this, and then we will walk through it in a minute, but at least try. Please give your best effort. Again, pause the screen, get this done, and then we'll go over it here momentarily. Fam, did you do the work? Or you just was like, hey, I'll just wait for him to, nah, don't do that. Do the work. That would be like us going to the gym and then me being like, okay, I can show you how to do some stuff, and until I actually do anything, you don't do anything. Nah, you got to work out. You got to do the work, okay? So do the work. So again, right now you can pause the screen and do the work, and then I want you to at least try, okay? Okay, so let's take a look at these, all right? Let's go. So I'm going to walk through all these things, and we walked through these on yesterday's lesson. Just remember, this is like a trip, so where are we going? So we need to convert 15 newtons, right, in weight into pounds. So that's where we're going. We're going from newtons to pounds. Now that we know that, now we know what to do with the conversion factor. So the conversion factor says whatever we're converting to, that needs to be on top. So I'm going to go with 1 pound and put that over 4.45 newtons, okay? We're going to times that times the 15, because that's what we're converting, okay? 15 newtons over 1 is equal to. So then we can cancel the newtons there, and then 1 times 15, or 1 pound times 15 is 15 pounds over, and then 4.45 times 1 is 4.45, okay, is equal to, and then now we're going to have to do a little bit of calculating. I think my calculator's on the other screen though, so I'm going to have to like pull that thing over. Here we go. Sauce, put it right here, and then say 15 divided by 4.45 is equal to 3.3707. We're not going to get lost in the weeds, okay? So we want to round to 1 decimal place, so that should be 7 or more up, or 5 or more up the score, so it's a 7. So we're going to go to 3.4, and then we're going to keep our same units, okay? So 3.4, and we have pounds right there. So that is what goes right there. Boom. LB. All right, cool. Let's just go to the next one, okay? And we're going to go down here. And again, same question. Where are we going? What are we trying to do? What are they asking for? So convert 100 pounds in weight in newtons. So we're trying to convert it into newtons. Using the conversion factor, again, 1 pound is equal to 4.45 newtons. So again, this time, since we're going 2 newtons, then this is what should be on top, newtons. So we'll go 4.45 newtons divided by 1 lb times, again, 100 lb over 1. So set that up in a very similar way to when we did this one. However, since we're going to newtons, then that's what this is for. So then 4.45 times 100 is 445, right? But let's look at these units. So we're canceling the pounds, canceling the pounds. So we have newtons left there. Newtons over 1. And there we go, 445 newtons. Now, if you were able to follow that easily, you were able to solve those on your own, then you're probably in a good space. If not, we're going to be doing some practicing along the way. So each day this week, so make sure you're paying attention, make sure you are practicing. I would go back and maybe do a couple extra problems, which I can put out some extra problems if you would like some. I'm sure you can find some conversion factor problems too. But just let me know if you want some extra problems to try and solve. Okay, cool. So last thing here is, when you need me, you throw me away. But when you don't need me, you bring me back. So what is it? So hopefully you're seeing like, some people said a boomerang. Some people also said the cooking instructions. Keep throwing that package in the trash. I was like, boy, that's smart right there. However, the answer is an anchor. You throw me away, but then you bring me back when you need me. Yeah, that is definitely an anchor. But I do like boomerang and the cooking instructions. That's clever. Okay, so we are going to talk about the lab just a little bit. Long story short, I'm not going to go into super detail on here because most of those details are for, it seems like something's not right. Hold on. It seems like my camera is stuck. However, it seems like it's still recording, so I'm just going to keep going. So, long story short, though, I'm not going to go into super details about the lab stations and all of those things. For the people who missed the lab, I'm going to post a virtual version, not a virtual version, but like a video version of the lab. But for the people who are in here, I'll give you the lab instruction. But let's just do the first one together so you can get an idea of how it's going to work. Also, I wanted you to see, and hopefully you can actually still see me. Oh yeah, I guess you can. I guess it's been working. So on page 17, that's where the lab begins. But if you turn to page 18, 19, 20, 21, and 22, that's how far the lab goes. So I want to make sure that you see that the lab goes from from 17 all the way to 22. So make sure that you got that. So we're just going to do the first one. Now, I will say this. At each lab station, there will be a set of lab instructions at each lab station. We're just going to go through the first set of instructions. That way you can get a feel for how all the lab will work. Okay, so I'm not sure where it stopped, but in the video, just so you know, at each lab station, there'll be a set of instructions. They will look just like this. So we're going to go ahead and do exactly what this thing. Hopefully you can see the video. If not, just listen to the instructions and I'll use the pointer arrows, and that way you guys can at least see the stuff on the screen. So it says keep your hand flat on the surface. So we're going to keep our hands flat on this surface. And then it says tap it or slap the surface lightly. So we're just going to... Okay, cool. Then it says repeat the process, but this time slap the table much harder. Make sure don't break your hand, don't break the table. So here we go. 1, 2, 3. Now, what did I feel? Now, hopefully you did that with me. What did you feel? Hopefully you felt something. So again, what did you feel? What did you observe? And I felt like some vibrations in my feet. I felt vibrations here. I felt tingling. I felt a lot more pain, right? So let's just describe what are the boundaries of this system real quick. Hopefully you see it as the boundaries of this system, right, are the table. That's exactly what I would say is the boundaries of the system, and that's this question right here. What are the boundaries of the system? I would say edge of table. Cool. And then what are the interacting parts? I would go with table and hand, right? That's the interacting parts of the system. And how are they interacting? Hand slaps table, right? Slaps table And table, well, it does what? Stops. Table stops hand. Something like that. That's something like what I'd put. Okay. Now, on to this next part. Let's just go on to the next part, okay? Bam. Let's do our drawings real quick, okay? So you can have your drawings be as simple as possible. And for a diagram, you just need some visual representation of what's going on. So I had a force going down. And what do you think that is? Hopefully you said, I believe that might be your hand. I also felt like there was a force going up because it stopped my hand. And I would be like, that's the table. Okay, cool. Now, there was a going down this second time. It was a much bigger force. And then going up this second time, it was a much bigger force. And I still, again, I would say that was the table. And I would also say this was the hand. Now, we're going to be looking at action-reaction forces this whole time. So there was an action force going down, and it felt like there was an action force going back up. Because that's how my hand stopped. Or else if there was nothing to stop my hand, it could just keep going, right? And I also felt the pain from the impact or the force that was being applied, right, like back to my hand. So again, we're going to look at that throughout the rest of these lab sections for the rest of this week. So just make sure that you have read through the lab, just at least breeze through it to at least have an idea of like what's going on. And then we are going to start this lab tomorrow. So tomorrow I'll talk for just a couple minutes, then we're going to get up and then we're going to go to all of the lab sections. So just make sure that you are prepared. Okay. All right, y'all. Peace.